Programming communications is one of the most challenging tasks, especially when starting from scratch. Is it the cable? Is it the wiring? Is it the connector? Do I need a resistor? Is it the configuration of the network? Addresses, baud rates, parity, stop bits. Do the devices support all the codes? How many nodes can I have in the network? Is the network overloaded? How does the communication block work? We can't tackle all this in a 10-minute video, but we can program a simple read VAR and write VAR in a PLC. We're going to demonstrate how to configure Modbus serial in Unity Pro and program the read VAR and write VAR function blocks. The native Modbus port on the M340 supports either RS232 or 2-wire RS485. We have our PLC programmed, the serial port on the PLC programmed as a master, 1 second timeout, RS485 2-wire, 19.2K baud, 8-bit RTU, 1 stop bit, even parity. The Modbus device that we're using is set to address 3, and all of the configuration parameters are set identically. 19.2K baud, RTU, 2-wire 45, even parity, 1 stop bit. So let's look at the read VAR function block first. As we look at the read VAR function block, we have ADR, which stands for the address. This is the address of the device we're talking to. The object type, this is whether it's a 4X register, 3X, 0X, or 1X register. The first object that we're going to read in the Modbus device, so this would be address 4003, let's say. The number of objects we want to read. So let's say we want to read 10 objects. It'll be 4003 through 4012. And we have the receiving array. Where are we going to put the values of those registers we're reading from the device in our PLC? Write VAR is very similar to read VAR, only we're writing. So the basic difference is an input into the write VAR function block with the values of the data that we want to write. Both the read VAR and write VAR have the input-output pin GEST, which is the Communication Exchange Management Table. GEST is a 4-element array of words. The Exchange Management Table, when we open it, the first element of the Exchange Management is read-only. The PLC assigns an exchange number and sets the activity bit. The activity bit is set to 1 while the function block is executing and resets to 0 when the execution is complete. The second element of the Exchange Management Table is critical when you're debugging during the commissioning of a project. The communication report is basically a list of the error codes that you can get. So if you're not using the second element of this array, it's difficult to troubleshoot and you won't see any data. The third element is the timeout. You will forget to program this timeout. It will be 0. You should not forget to program this timeout. You will have trouble when you forget to program this timeout. And this timeout must be set greater than we set the timeout on the serial port itself. So in this case, our answer delay timeout is 1 second. In our example, we're going to set a 2-second timeout. Now you will forget to program this timeout, and that is bad. Do not forget to program this timeout. I would recommend programming this timeout. A value of 0 will wait forever, and none of us have the patience of Job. So the fourth word of this array is the length. This is written again by the PLC. It is the length in bytes of the communication exchange. So if we're writing or reading 10 words, this length will be 20. So let's program the read var. I'll create by right-clicking, new section, a new project called read underscore write underscore section. It's a function block section, so I will say OK. I will go to my function block input assistant. I will click it, and I am just going to type read var because I know that's what the command is, or the function block is, and I will slap it right in my logic. Now when the read var executes, I'm going to show the enable out. Each time the enable comes on, and I'm going to one-shot to it, it will execute this function block once. So first we'll put the address in. The address command is addm. It's a string, so I put an open quote, rec 0, slot 0, channel 0, Modbus device 3. I will close the quote, and I will end my parentheses. The type of object we're going to read from this Modbus device is going to be a 3x register, which is an input word. This is also a string. So it's open quote, %IW, close quote. %IW is the IEC standard for a 3x register. Now, where are we going to start reading from? We'll start from address 3003. And the number, let's read 5 registers. And we'll create an array, and we'll call it input from device. And this is an array. We're going to read 5 registers, but I'm going to make this array 8 because I know I'll have to read 3 more eventually, and I will hit the check mark. And then I'm going to set the exchange management table. I've already created a variable to do this, so I am going to call this the Modbus read parameters. And I am going to put a one-shot, which is r underscore trig. And I'll put him up here, and I will create a variable called read the variable. I will check. Oh, I have a space in there. No spaces allowed. Check and create. I will create the link from the output of the one-shot to the enable. And then I will go to the variables. I will look at my Modbus read parameters, and I will not forget the timeout. So I will go to the value, and I will select a 20. Because if I forget that, that would be bad. We'll go back to my section of logic, and we will test this section of logic. So I will I'll rebuild the entire project. Yes. I am built. I will say PLC connect. The PLC is different. PLC transfer project to PLC. Stop the current project. And I am up and running. So I will grab my Modbus parameters and my input. I will right click, I will create a new animation table, and I will look at the devices, and then I will also add my read the variables. I've got my 20-second timeout. I did not forget that, which is very good. I will set the read the variables one shot right here. And you see I get values. Now, let's look at the first table in hex. So 39 is the exchange number that we received from the PLC. No errors, because I'm 0 here, but in case there is an error, I'm going to set this to hexadecimal as well for the communication error in the operation report. And then I get the 22nd, and I've read 10 bytes. So let's issue the command again, and you should see some of these 5 registers change, and there they go. No errors. Disconnect the cable from the device. We will see the activity bit come on, and then we will see an error after 2 seconds. There's your error, error 1. If I go back to the help and I look at the communication report, I can see the error is exchange stop on timeout because I pulled the cable. Let's put the cable back together. Let's go back to my PLC. And let's reset the exchange. Resets, and you see the value change. Now watch the values here. And that is the read VAR. I think we'll create another video to show you how the write VAR is written, and then we'll create a sequencer to sequence between the two.